All right, let's get started. Good afternoon, everybody. Welcome to a nice sunny afternoon of Chem 170 with your host, me, Dr. White. Hi, everybody. Hopefully you had a great weekend. I spent a lot of it grading tests, gave a test in here, and my other class at College of DuPage. So I was busy. Guess what? Grading. Don't you feel sorry for Dr. White? Anyways, that's part of the job. All right, test number 2. You all should have gotten an individual email that showed you the points you got for each answer on test number 2. In a little while, I'm going to go through all of test number 2 like I always do. Remember, if I made a mistake grading, let me know by email. You should never, ever, ever be penalized for a mistake I make. So send me an email and I'll recheck your test. And if I made a mistake, I will correct it. On a nice note, got a secret for you. You people are learning organic chemistry at a very high level. Thank you. Makes my heart feel so good. It does. And I'm so happy. The average was about 90-ish, which on test 2 is fantastic. Thank you. All right, what we're going to do today, and go through test number 2. Afterward, I'll show you how to figure out what your current grade is. Next, I'll go back to working on esters. Now, one thing about grades, ECC requires all faculty to submit a midterm grade. That means nothing really, other than I take your 2 tests, divide them by 2. That number was 90 and above, I gave you an A, 89 B, and so on. But there's still plenty of points left to go. Questions? Actually, I should go like this because the speakers are up there. They're cranked up too because I don't have my hearing aids in. All right, well, I would have a question if I were you, and that's, we've just hit the midterm. Actually, this is week 9. Do you realize half our time together is gone? Oh, that's sad. But I would ask the question, well, half the semester is gone. What grade am I getting? Well, I better answer that. That's not what I want. Let me just shut this down. All right. What grade are you getting? Or are you right now getting? There are 2 methods I can use. Method A, and that's test number 1 score plus test number 2 score divide by 2. That equals the number X. And for this class, and this is assuming you've handed in all your labs up to date, except the one doing this Wednesday, and you people are up to date, thank you. And if X is 90 to greater than 90 or equal to it, you're getting an A at this point. If you're getting 80 to 89, you're getting a B. And I don't have to go any lower because nobody else is. Yay, thank you. Now, there's also a method B. As stated in my syllabus, the lowest of 4 tests are dropped, and it's based on 3 tests, your final, and the lab total. So method B would be I can spell, which I can't. Pick either test 1 or 2, whatever that score is, and let the higher that, and we'll call that Y. And if Y is greater than or equal to 90, you're getting an A. And if it's 80 to 89, you're getting a B. And most of you are doing, like all of you are doing well. And if you have any questions where you stand or anything about anything with this course or anything else, feel free to ask. Anybody have any questions? Well, let's move on. And let's get back to what we were talking about last week. And that was esters. And remember, we went through the nomenclature of esters and also carboxylate anions. Let's look at an ester. I still keep him about that course time I taught this at the other school. I had an ester in my class. Every time I said Ester, her head would whip around. Did you call me? She was glad when that chapter was done. And the first thing you have to look at is what functional group do you have there? What's different? Ooh, 2 oxygens. We have carbons, carbonyl, oxygen, and this is an ester. And how do you name the ester? You name R prime. The group on there is the alkyl group in front, isopropyl. I tell you, I love T-butyl. I also love isopropyl. Not as much T-butyl, but a whole lot. And then there are 2 methods. If this were an H, name that carboxylic acid, drop the IC and the word 8, and add OAT or ATE, drop the word IC and acid and add ATE, or as that one very sharp student I had in the past, 170, figured out with this, what's the longest chain with the carbonyl carbon? 1, 2, 3, 4, 5, pentane. And drop the E and add OATE. And that's isopropyl pentanoate. And because it's, wow, we've gone over a half hour and I haven't shared with you some of the fun, I'm going to let you have some fun. Name this compound. I hope you all had a good weekend. By the way, if you haven't figured out, it's officially fall now. How do I know that? Well, last Friday, I turned on my furnace for the first time this season. When I do that, I crank up the temperature so it runs for about 15 minutes or so. So anything, dust or whatever, spider webs or who knows what, in the furnace burns off, and you get that burning smell for about a minute or so out of your vents. And not to get scared, I always do that. So I know, all right, it's done. In about 3 weeks, in November, I'll have my annual furnace checkup and maintenance call. By the way, if anybody ever needs a good company that installs top brand furnaces and also does outstanding maintenance, let me know, because about, what was it, in 2015 or 14, I needed a new furnace and air conditioner for my house. And I asked the person who was in charge of HVAC, what would you call it, classes at ECC, who's a company he would use. He said, well, I do my own because I'm an HVAC person, but this is a company I would send anybody else to if I didn't do it. And he was right. They, for now, well, since 2014 or 15, it's almost 6 or 7 years, they've done a great job of maintenance. They're not the cheapest, but they're the best. All right, let's do this. What do we have that's different? Carbonyl, oxygen to carbonyl, carbon there, carbon there. And we have an ester. What do you name R prime? That's N-butyl. And then 1, 2, 3, propane. Drop the E at OATE. And it'll be N-butyl propanoate. Aren't you glad I'm not giving enunciation quizzes? All right, now, when I talked about this nomenclature, I also talked about the nomenclature of carboxylate anions. And here it's the same thing, except step 1, name M plus my other class. I think the majority of the people I found out couldn't read cursive. That's sad. And so I'm printing. Normally I'd write this and you'd ask me, what'd you write? Well, you could figure it out. You name M plus from the, name it as the element it comes from, and you put that in front. Then 2, and 2, you name the rest like 2A or 2B or not to be. That's why I can't resist saying that. Sorry. I can ester. So let's go through 1. And by the way, you don't have to put charges down when you draw a structure. I will always. This is my good habits I don't break. If we look at this, what do we have? Carbonyl with an oxygen, anion, cation, and an R group. And this is a carboxylate anion. And we'll learn later, carboxylate anions help keep you clean, like your hands and other things. Yes. But anyways, so this one you have to use 2A. Can't use the student's method. First of all, Na, you should know, is sodium. And then the acid it comes from, if it were a carboxylic acid, and this is, I think, the only time when R is a benzene ring, you have to use the IUPAC 2A method. And this is benzoic acid. And there, you drop the IC and the word acid. And add ATE. So that's sodium benzoate. And I hope you remember that I talked about sodium benzoate because that's an additive in pop. Remember, that's the stuff in the cans or bottles that's non-carbonated or is carbonated, non-alcoholic. And Dr. White likes his Dr. Pepper and Werner's. Ooh, time out for a public service from Dr. White. Everybody see on your, I've been drinking this for years. I think my father liked it, and that's how I found out about it. And it's a very spicy and highly carbonated ginger ale. And I love this stuff. You can get it diet or regular. I get the regular. I'll talk later on this semester. Did I talk about, yes, I did. I talked about diet and artificial sweeteners when we talked about alcohols. And I used to drink diet. I found out stuff they put in artificial sweeteners is bad for your flora in your intestines. It kills them. Doesn't harm you, but it helps you gain weight, even though it's supposed to not do that. Anyways, this stuff is great stuff. Every Jewel I've ever been at sells this. Some other stores do too, but I always buy it at the local Jewel. And now that was my public service announcement. All right, I better give you a all right, what's the IUPAC name for this compound? Now remember, my gift for both esters and carboxylate anions, even though I know the IUPAC rules on R, I will never have a substituent. Either here's the structure drawn, I'll give the IUPAC name, or here's the name, draw the structure. And when you're done, give me a thumbs up. Thank you, Joe. Thank you, Calvin. Oh, by the way, I hope you don't mind me asking this. Calvin, how's the weather in Champaign-Urbana?
It's been pretty nasty most of the week, but it's sunny out right now.
What's nasty? A lot of rain?
Lots of rain. It's been super wet out all week.
Send some up north. Thank you for that weather report. All right, let's do this. What do we have? What's different? Carbonyl, ooh, oxygen minus, and a cation, lithium. And what is this? This is a carboxylate anion. So how do we name it? Name the element that the cation is from in front. And then I already did this up here. This is benzoic acid. If this was OH instead of O minus Li plus. So drop the IC and the word acid from benzoic acid and add ATE. And that's how you do it. Now, there are two nomenclature skills. One is, here's the structure, give the IUPAC name. The other is, here's the name, draw the structure. I'm going to let you solo on yourself, by yourself now, and why don't you try this? Draw the structure for methyl heptanoate, 3 points each. If you know anybody who needs Chem 170, a one semester course, and they're anywhere in the world, because I'm going to do it fully internet like this semester, let them know. I'll be teaching it this spring semester at ECC. And you can, like I said, be anywhere in the world and take it, as long as you have internet access. And when you're done, give me a thumbs up. All right, I think everybody's done, so I better get to work. How do you decode this? Know what to draw? Start from the right, move left. OATE ending tells you that could be an ester or a carboxylate anion. And how do you tell the difference? Look in the very front. You see an element, it's a carboxylate anion. You see the name of an alkyl group, it's an ester. And we see an ester alkyl group, heptanoate, OAT ending. Now we know it's an ester. That were E heptane, 7 carbons. I have a carbonyl, oxygen. And what's my R group? Right here, R prime, methyl. I know there are 4 bonds to carbon. And there you go. Oh, let's do another one. And that is potassium octanoate. I see a few people are done, but I'll give everybody time to finish. I do that in a face-to-face classroom too. Everybody's finished. So how do we decode this? You start from the right, move left. OAT ending tells me it could be either an ester or carboxylate anion. And how do I know the difference? I come down here and look in the front and I see an element name. And that makes it a carboxylate anion. So if this were E-octane, 8 carbons. And at the end, carbon, I have a carbonyl. Oxygen, you don't have to put the charge there, but I do, O minus. And what's the cation? Potassium. And there are 4 bonds to carbon. And there's the molecule. By the way, that's a bit bleh. A better looking too. And that's how you name carboxylate anions and esters. Now I have to ask, did anybody happen to pick up a bottle of vinegar or a bottle of ketchup or mustard or a jar of pickles and see vinegar? Ooh, that's acetic acid and water. And acetic acid is a carboxylic acid. And ketchup and mustard and pickles all have vinegar, which vinegar, as you know, has acetic acid, which is a carboxylic acid. Did you do that? Did you happen to use some nail polish? And it was ethyl acetate, which is the common name for that ester, because nobody calls it ethyl ethanoate. Oops, I just did. Did you do that? Oh, come on. Did you pick up a bottle? This is not pop, but if it were a can of pop, and look and see it's got sodium benzoate, and that's a carboxylate anion. It's the preservative in the pop to make it stay longer, which is a good thing. Did you do that? Remember, organic chemistry is all around us. My video camera cuts off this part of it. But anyways, I stole that from SpongeBob because he did it with imagination, but I'm doing it. Organic chemistry is all around us and it won't hurt. I promise for you to think about it when you're outside my class. Now, thinking about outside my class, it's about 30 seconds or less before our break time. So I'm gonna give you an extra 30 seconds or more. Let's take a break, come back in about 5 in 1:55. I'll see you in 5 minutes. I can go get up and stretch. All right, let's get started. Oh no, I'm running a minute late. I'm sorry. All right, let's get back to esters. One of the nice things about where we're getting into this semester is we can talk about where we find these functional groups in our daily life. So let's talk about esters. And where can you find esters? Well, one of the interesting things is esters are responsible for the flavor and the fragrance of many flowers and fruits. Now, let me open up this. Does everybody see on your screen ester name and odor or occurrence? And if we look at these different esters, like benzyl acetate is found in pear, strawberry, and jasmine. Now, one of my favorite is, let's find it. Oh, I can't find it. Ethyl hexanoate is in pineapple. Here we go. This is isoamyl acetate. And isoamyl is a alkyl group I haven't talked to you about. It's a common name. There's also an IUPAC name for that alkyl group. And that's really the key chemical that gives the taste and smell of bananas. So next time you're smelling a banana, you're really smelling isoamyl acetate. Now, if you notice, there's a lot of different things, different esters. Here's one from strawberry. Where's N-octyl? Here we go. Octyl acetate, N-octyl. And that, if you smell an orange, that's what you're smelling and tasting. So next time you have certain fruits and also certain vegetables, and they're in them too, what you're tasting and what you're smelling is an ester. Is that amazing? But you never thought that was organic chemistry. It is. Now, I'm going to skip this one, pentyl acetate or isoamyl acetate, bananas. Now, someone took the time to isolate all these different esters, and some of them are complex, which I haven't taught you. Some of the groups here are found in the volatile esters, meaning the ones you can smell from scented roses. I don't know about you, but Dr. White loves roses. I love to smell flowers. Now, here's another important thing. Perfumes are mainly esters. The next time you use or buy a perfume, remember men is called cologne, but it's really perfume, but they give it a different name. You're buying a complex mixture of esters, and those make you smell good if you put it on. And mainly, well, I take it back. In the last decade or so, more and more men are wearing cologne, but mainly women wear perfume. Now, remember the first day of class, I said I'd tell you some stories and you learn a lot about me. This one's an interesting story, not one I'm proud of, but it's true. It's a real story. First of all, I grew up in the Skokie area. I don't know if you know where Skokie is, Illinois. It's just north of Chicago, in between Skokie and Chicago is Lincolnwood, where I really grew up in. And in Skokie, they had years and years ago when I was in high school or even younger, one of the first big outside open malls, period, shopping centers. And that's called the Old Orchard Shopping Center. I think it's called a slightly different name now, but everybody still calls it Old Orchard. In Old Orchard, they had back then a very large Marshall Field's, now Macy's. Now, when I was in high school, and I knew other friends of mine had the same unfortunate skill, I could get my mother mad at me like that. I mean, really tick her off, so she'd go ballistic. And later that afternoon or evening, my father would come home from work. My mother would be all upset still at me. And he'd take me, let's go downstairs in the family room. He'd look at me, and I was very close to my father, great man. And he'd look at me and give me that look. All right, what the heck did you do now? Now you know how to get out of the doghouse, so you better do it. I said, all right, I'm sorry. He says, use your brain, stop doing those things. When I got through at high school and got into college, I was a lot better. But in the high school years, oh, it was bad years between me and my mother. We bad fights, verbal, luckily, that's all. But how would I get out of the doghouse? Simple. I'd go to Marshall Fields and I'd buy her favorite perfume. And that was Chanel No. 5, which, if you know your perfumes, is very expensive. Well, during my high school years, the women behind the counter at Marshall Fields in Old Orchard got to know me. When they saw me coming up to the counter, they'd look at me and say, did you get your mother mad at you? Yep. How big a bottle do you need? The madder she was, the bigger the bottle. Not the big one that was a couple $100, but still it was a good dent in my money in my wallet, which in high school was limited at times, but that's how I got out of the doghouse. And that's my perfume Chanel No. 5 story. And it always worked too. Gave my mother a bottle of Chanel No. 5 and all was forgiven. Now, one other thing I'd like to talk about, and I'm going to talk about this in terms of organic chemistry, nothing moral, and that is esters in nature are responsible for what's called sex pheromones by animals. And those are the chemicals, or mainly one chemical, esters, that usually it's the female of the species emits when the female is into heat and trying to attract the male for procreation, sex. And if you've ever been around dogs or cats, when a dog goes into heat, all the male dogs in the neighborhood know it because they can smell that ester. Now, interesting thing, for many, many eons, people have been trying to find out, is there a sex pheromone for humans? And so far, the answer is nobody's found it. But that doesn't stop people from selling perfume and other things as, well, this could be a good sex pheromone. Now, every once in a while, you'll hear on the news, oh, scientists found this. And a couple of years ago, I remember they had it on the radio and TV, everybody was saying, and these scientists found that this is a sex pheromone. What did they find? It was male sweat attracted females. I don't think so, because if you go to your local place to get perfume or cologne, you're not going to have eau de sweat. No, but they thought for a while. Now, that hasn't stopped advertising. In the old days, we used to call them Madison Avenue, from using that concept. And every couple of years, they come out with the same concept for men. That is, buy our product, splash it on yourself, and you'll attract all these beautiful women, like a sex pheromone. And I saw a commercial a couple of days ago on TV, and I think it was for the men's cologne Axe. And this guy, sort of nerdy looking guy, puts some on, goes on a bus, and this beautiful woman just about attacks him, and they go flying out the window, happily ever after. No, there's no sex pheromone, even though smell good can attract people. All right, now, how do you make, oh, one other ester. If I'm giving you a headache, you might want to take aspirin. And if you notice aspirin, and you don't have to know the structure, has an ester here. It's just drawn this way because I took the structure from the internet. And it's also got a benzene ring, and it also has a carboxylic acid. Now, how many of you ever heard of the product bufferin? And bufferin is better on your stomach, doesn't upset it as much, some people, for aspirin. And what they've done is react this with a base to make a carboxylate anion, which is less acidic and therefore gentler in your stomach. Now, originally, the chemist who invented or discovered aspirin, his father had that problem, and that led him to make bufferin. Now, how does this get rid of things like headaches? I have no idea. I know how to make it, but I don't know how to explain how it works. And recently, if you've been following for many years, medical science and the people who make aspirin are telling you, take one a day, and it'll help you from not getting a heart attack. And recently, in the last 4 or 5 months, I forgot when I heard it, they're now, a lot of medical researchers are saying, you really shouldn't take this for preventing heart attack. Why? Because aspirin has a very negative effect on your stomach and GI tract, and those negatives outweigh any benefit this would do to your heart. So ask your doctor. How do you make an ester? And it's the Fischer Esterification. And a Fischer is named after the great German organic chemist, Emil Fischer. Now, this alone would be a lifetime achievement, this reaction, discovering it. But he's also really known for his work with sugars, which I'll talk about. And that work with sugars he did actually killed him at an earlier age than he should have died. Sad, but true. All right, let's look at Fischer Esterification. And what do you start with? You start with a carboxylic acid. You react it with an alcohol, and you need acid catalyst, H+. Usually this is sulfuric acid, but it can be other acids too. Not HX, but others that I don't teach you, like methane sulfonic acid and toluene sulfonic acid. And what you get is an ester. The R prime group with the hydroxyl OH group will be the carbon bonded to this oxygen there. And for those who must, just quick, write this down in your diary. Dr. Wright actually put down something inorganic, and you get water, which you can ignore. All right, let's take this for a spin. And if we look at the following reaction, the question is, what's the product or products, excuse me, that you would make with this reaction? If we look here, what's different? Again, look for what's not carbon, what's not hydrogen, oxygens, and carbonyl hydroxyl carbons, that's a carboxylic acid. Carbon hydroxyl group, that's an alcohol. And we have acid catalyst, H plus. And what do you get? An ester. So if we look here, here's my R group, here's my R prime. What's ever attached to carbonyl is still attached. So I have my CH3, CH2, carbonyl. Now I have an oxygen. What's my R prime? Methyl. And there I've made an ester. I just thought of something sad. And that is, not this week, I think it's in 3 weeks, the lab you'll be doing, unfortunately online. In real life, I have you make a number of esters and smell them. And it's a lot of fun. But you can still smell them at home if you can find the products. So that's how you make an ester. All right, it's your turn. And the question is, give the organic product or products for the following reaction. 3 points each. And don't forget, if you have any questions or need any help with anything, tonight from 5 to 6:15 on Zoom, I will have my office hour on Monday. I also have one on Wednesday too. Thank you, Joe. Hint. I think Tam's done. And it looks like everybody's done, so I better get to work. And the first thing you have to do is identify what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond. Ooh, oxygen here and here to the same carbon. I have a carboxylic acid. Ooh, carbon, 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 hydroxy group and a carbon, alcohol. And I have acid catalyst. And this is Fischer Esterification. And we honor the great work of Emil Fischer by calling it after him. And therefore, I make an ester. What's our methyl? What's our prime and propyl? So I have my R group, my carbonyl, my oxygen, and what's our prime? 3 carbons. Which carbon is the hydroxyl group bonded to? The N carbon. Therefore, the N carbon would be there. Oh, this is fun. I've got to do another one. And here you go. Give the organic product or products for a following reaction. And while you're doing that, I can get a refill on my water bottle. Be right back. Good news, I'm back with a full bottle of water. I just remembered something. All right, time out for Dr. White's story. When I was in high school, we had our homeroom teacher who was the physics teacher. And I think it was my junior year, I took physics and he was the one who taught it. It was in the afternoon and he was much more mellow and interesting in the afternoon. I don't know how we found out, but he used to spike his milk that he had with lunch with vodka. So in the afternoon, he was having a good buzz. All great memories from the past. I don't think he's alive anymore, so I don't have any problem telling this story. All right, let's take a look at this. What's different? Carbonyl with a hydroxyl group in carbons, and that's a carboxylic acid. Now, if you notice, it has a benzene ring in there. Do you know of a reaction of benzene with an alcohol and acid? Because I don't. And that's the beauty and the power of functional group chemistry. If they don't react, guess what? They're not going to. Unless you know some magic that I don't. You have a magic wand, even then it won't. All right, what's different here? Carbon with hydroxyl group carbons here, alcohol. Acid catalyst, and what do you make? An ester. And what's R? My benzene ring. What's R prime? Isopropyl. And therefore, I have my, I'll move this arrow going up. I can do that on a whiteboard too in the classroom when I run out of room. You have a benzene ring, carbonyl, oxygen. Which carbon in the alcohol has the hydroxyl group, the center of 3, and that's going to be the carbon bond to the oxygen there. Center of 3, isopropyl group. And we just made isopropyl benzoate. Now, on test 3, just like test number 2, I'll have 3 or 4 synthesis problems. So I better have you try the following. And there you go. What would be the 2 things you react with acid catalyst H+ to make that molecule? This is the fun part of organic chemistry. But then again, I'm biased. I'm a synthetic organic chemist. Remember, synthesis or synthetic is a fancy word to make. That's my training, how to make molecules. Yeah, I see Joe's done, but I'll wait for everybody else. And one thing I forgot to mention, I will cut out the part where I went through test number 2 answers from the video. But if you ever need to see anything like from the answers for test number 2 or any test that I've already given, always feel free to see me either after class or during my office hours. And when you're done, give me a thumbs up. All right, I think everybody's done, so I'm gonna get to work. If we look here, what's different? Ooh, oxygens. And they're bonded to the same carbon. Carbonyl, oxygen. This oxygen has carbons. I'll call them R prime. My carbonyl carbon double bond oxygen has carbons. So what do I have? An ester. And how do you make an ester? You take a carboxylic acid plus an alcohol, and you react in the presence of acid, H plus, and you get an ester. So what's our isopropyl? What's our prime? Ethyl. And therefore, my R group, now I have my carboxylic acid, functional group, R prime, ethyl, and I'll have ethanol. And that's how you do it. Oh, we got to do one more. I worked for a company that made esters and also carboxylic acids and carboxylate anions, unichemical chemicals. And here's one more. What would be the organic product or product for the following? Oh, excuse me. Thank you, Megan. Thank you, Joe. And thank you, Tam. And it looks like everybody's done. Now, let's do it. What's different about this first chemical? Carbonyl, hydroxy group on a carbonyl carbons. It's a carboxylic acid. Second molecule, carbon-carbon hydroxy group on a carbon is an alcohol. Acid catalyst, and what do you get? An ester. And what's our methyl? What's our prime? Ethyl. So I have my methyl group, carbonyl, oxygen. What's our prime? Ethyl. And that's the ester you make. Anybody see the significance of that reaction? I'll let you ponder that. Ooh, it's time for a dollar word I'm going to throw at you. I'll let someone opine on the significance of this reaction. I haven't used that word in a long time, probably won't again. That means say something or pontificate or discuss it, opine. All right, my turn. Well, what if you were on a desert island or somewhere else and you had nail polish that you wanted to get off your nails and you didn't have a nail polish remover? Well, what if you had vinegar, which is acetic acid, this carboxylic acid, in water? And what if you had some vodka, which is ethanol, this compound, and you just happen to have some sulfuric acid, you react together, you make ethyl acetate. This is the common name for this. Nobody ever calls this ethyl ethanoate, the IUPAC name. And that's one of the key molecules used as nail polish remover. That's a mental exercise I like to do. What if I were stranded and I needed something? How would I make it with other things I have on hand? And it's just a fun mental exercise I like to do. Now you know I'm an organic chemist. All right, so the Fischer Esterification, carboxylic acid, alcohol, you make an ester. Well, now that we have an ester, what can we do with it? Well, if you're reading the book, I'm not doing mechanisms in a one semester course. I can do it, but I just don't have the time. Switches off a certain type of ester, or a certain organic chemist decided to give it a name, and that's called lactones. And that's made from hydroxy acids, where you have the alcohol and the carboxylic acid in the same molecule, and you make a lactone. Why they just didn't call it an ester? And lactones will not be on test 3, will not be on the final. Now, what can you do with an ester? And here, this would be a carbon. You can react it with water and acid. Now, it turns out this is going to be a very important reaction that we'll talk about later. But first of all, I think I might ask this question, but I'll ask it again. Wherever you are right now, or like where I am in my office in my home, if I needed acid and water that quickly, where would I find it? Or where would you find it in wherever you're sitting right now, your surrounding? Where would you find a mixture of acid and water quickly? Anybody? It's in your stomach. Your stomach has acid and water, H+. Now, I always think of it, and it just boggles my mind that you and I have cells in our stomach, and I think they're small intestine. But remember, last time I took biology was freshman year of high school. That was a long time ago in a galaxy far, far away. But anyways, you have cells in your stomach that make hydrochloric acid, H+. And if you've been doing like I've been doing, the medical science says, drink plenty of water, I just put water in my stomach. And let's look at the reaction. And that's if you take a ester and react it with water and acid, you get back the carboxylic acid, excuse me, and the alcohol you would have used to make that ester. Again, start with an ester, carbonyl OR and R group on it. And if I react it with water and acid, sometimes I'll even write it this way. And both this way and this way are the identical reaction. And what do you get? You get back the carboxylic acid plus the alcohol you would have used to make that. Now, later in the semester, I'll be teaching about fats and oils. Like if you had a hot dog hamburger, or if you have potato chips, you consume something with fat or oil in it. And this reaction, acid hydrolysis of an ester, is how your body breaks down fats and oils. As I'll teach you later, all fats and oils are esters. So next time you consume something with fat or oil in it, or if you have an oil vinaigrette dressing on your salad, if you have hot dogs, hamburgers, or other things with fat in it, bacon is a big one. Dr. White stays away from bacon, so I love it too much. But anyways, this is what's going on in your stomach, and we'll talk more about it when we get into fats and oils later in the semester. So let me just write the same thing, because you get the same thing. If we take this and react it with, here's another way I could also write it, acid and water. The question is, what's the product or products for the following? And by the way, on test, I'd put a plus, so you know there are two things you have to do. Well, what functional group are we dealing with? Carbonyl, carbon double bond to oxygen, oxygen with carbons on it, and the carbonyl carbon has carbons. And what is this? An ester. And if we react it with water and acid, or acid and water, same thing, you get back the carboxylic acid plus the alcohol you would have used to make that ester if we went back that way. So what's R? These three carbons. What's R prime? 2 carbons. So I have my R group. And then I'll have my carbonyl. Something tells me this is going to lock up in a second. And I made a mistake. Somebody should have caught me. That should be an H. Sorry about that. Well, I did tell you the first day I do make mistakes rarely. Sorry about that. So I have my carboxylic acid. What's my R prime? And the carbon that's bonded to this oxygen will have the hydroxyl group. And I've made that ester. I'm not ester, carboxylic acid. I got ester on the brain. Carboxylic acid plus alcohol. And that's how you do it. And here's one for you to try. Have fun. Don't forget, this Monday, the distillation lab is due, and we'll be doing a fun reaction on Wednesday, talk about in lab. Oh, it's going to be fun. Now I get to teach you about a new piece of equipment called the Buchner Funnel. I actually have a collection of Buchner funnels in my living room. Now you know he's an organic chemist for sure. And when you're done, I forgot to do something here. There. If you're done early, please be patient. I try and give everybody time to finish. Finish. It looks like everybody's finished, so I better get to work. And the question is, what functional group do I have here? Carbonyl, oxygen. On this oxygen, I have carbons. I'll call that R prime. On the carbonyl, I have carbons. I'll call that R. I have an ester. And what am I reacting with? Acid and water. And what do I get back? The carboxylic acid plus the alcohol I would have used to react together to make this ester. So what's R? Isopropyl. What's R prime? Methyl. So I have my R group and carboxylic acid. And then my R prime is methyl, so I'll have methanol. And that's how you do it. Oh, we got to do another one of these. Let's try a synthesis. All right, what would you react with acid and water to make these two compounds? All right, see, a couple people done. Remember, this is the fun part of organic chemistry, synthesis. All right, I think everybody's done, so I'm going to get to work. If we look here, what's different? A benzene ring, but more importantly, I have a carbonyl and a hydroxyl group, and we have a carboxylic acid. Now, if I look over here, carbon, carbon, ooh, carbon with a hydroxyl group, that's an alcohol. And I'll call this R, and my T-butyl group here, R prime. And what do we react with water and acid to make these two compounds? And the answer is an ester. And therefore, what's our benzene ring? Then I have my carbonyl, oxygen. What's our prime? The carbon with the hydroxyl group is a carbon bond to oxygen. So I have a T-butyl group. And I put in my hydrogens because, you know, there are 4 bonds to carbon. And there's the molecule you would start to make that. Those two products. Oh, let's do one more. Yeah, I've got time for our next break. And the question would be, what are the two products you would get if you react that molecule with acid and water? Thank you, Joe. Thank you, Tam. And don't forget, the rest of you, when you're done, give me a thumbs up. I think everybody's done, so I better get to work. What do we have here? What's different? Carbonyl with oxygen. On this oxygen, I have carbons. On the carbonyl carbon, I have carbons. I have an ester. And reacting with water and acid, that's what H plus is. Acid catalyst. What do I get? I get the carboxylic acid plus the alcohol I would have used to make that ester. And what's our methyl? What's our prime ethyl? So I get this carboxylic acid, my alcohol would be this. And these are two products you get. Now, once again, I'm going to play with your mind. I've been doing it the whole semester, but I'll do it more openly. Anybody see the significance of that reaction? Everybody give up? All right, you give up. What's this? This is ethyl acetate. Nail polish remover. And water and acid. If you were on a desert island and you wanted to make some salad dressing, have a good stiff drink, what could you do? Take the ethyl acetate, react it with acid and water, and you make acetic acid, which you purify and mix with water, and you got vinegar. And here you purify from the reaction ethanol, which is the active ingredient in vodka. And that's what you could do. And with that, it's time for a 5-minute break. Now that I've played with your brain. I'll see you in 5. Come back at 2:50. I can get up and stretch again. time to get going. All right, we're talking about esters. By the way, next time, well, it's getting fall. By the way, it's officially fall. How do I know? Well, last Friday, I think it was, I turned on my furnace, and I also moved all my short sleeve shirts and polo shirts from one closet, one bedroom, to the other. The one in that other room had my long sleeve shirts and polo shirts, and those got moved into my bedroom. So, you know, fall's here and winter's on the way. All right, what else can you do with an ester? Uh-oh, hold on. Time out for close stuff and open it again. I apologize for this. I got so many things open going on this machine that this happens. It has been for a while. I don't know if I have a corrupt file or just a memory problem. All right, let me just do one more thing. All right, sorry about that. All right, everybody see saponification on esters on here? Thank you. Now, next reaction with esters is called saponification of esters. Why? Because it was used for many eons to make soap. How many of you are familiar with the term lye soap? Anybody ever hear that? I see one person, two people. And what is lye? Sodium hydroxide. Lye is the common name for NaOH, sodium hydroxide. And the way you make soap, which I'll teach you later in the semester, the specific way is you take animal fat and react it with sodium hydroxide and water to make your soap. And that's why this is called saponification, because it was a way, and still today, to make soap. And I worked for a company that made carboxylic acids, also carboxylate anions that were used for soap, to the tune of about 2 to 3 million pounds a week. I'll talk more about that later in the semester. So what's the saponification of an ester? And that is, you take an ester and react it with water, now a base, you'll get a carboxylate anion plus an alcohol. And let's take a look at this reaction in detail. Now, the mechanism I'm going to show you will not be on the test, but I just wanted to show you this. And I'm going to change it slightly, where M can be sodium hydroxide. It can be lithium hydroxide, or it can be KOH, potassium hydroxide. And therefore, what do you get? You get two products, the carboxylate anion plus the alcohol. And this is the carboxylate anion of the carboxylic acid I would have used to make that ester. And the question is, why do you get a carboxylate anion? Well, let's take a look. And here, when we reacted initially with base and water, we'll get the carboxylic acid plus the alcohol you would have used to make that ester. But I'm going to put this in brackets. When you put it in brackets, that means it can't be isolated as that molecule. Why not? Because you learned earlier, a carboxylic acid in the presence of base and water, here's an acid, here's a base, forms the carboxylate anion. The fastest reactions in all of nature, all of chemistry, are acid-base reactions. So the instant you form this reaction will occur to form the carboxylate anion. Oh, that reminds me. Do I got time? Oh, I do. How many of you have ever seen a commercial on TV? I haven't seen it in a while, where they're trying to sell something like laundry detergent. They have this big glass tank with some clothes in there, and it's all cloudy. And they dump their product in there, give it a quick swirl. All of a sudden, it's clear. Have you ever seen that commercial? That's what we call in industry a dog and pony show. That's a bunch of garbage. Why? Because when they pour their product, and if it really is their product, that's another question, into that cloudy tank of clothes, and it goes clear like that, there's only one reaction that's that fast, and that's an acid-base reaction, neutralization, and it has nothing to do with how soap cleans your clothes. Later in the semester, yes, I will. I'll teach you how does soap work to get your hands clean, your clothes clean, your hair clean, your dishes, and anything else clean. Which reminds me, next couple of weeks, I'm going to have to double wash my car and wax it for the winter. I'll teach you more about wax later on. Actually, wax is an ester, but we'll cover that in fats and oils. So when you treat a ester with base and water, you get not the carboxylic acid, but the carboxylate anion and the alcohol, the carboxylic acid, carboxylate anion, the carboxylic acid you would have used to make the ester, plus the alcohol you would have used to make that ester. So let's try one. If we look at the following, the question would be, what would be the two products that you would get if you react this molecule with sodium hydroxide, NaOH, and water? Well, what's different about this? Carbonyl with oxygen, R group on the oxygen, R group to the carbonyl, that's an ester. And I'm reacting it with MOH, a base, where M can be sodium, which in our case it is. It can be lithium, or it can be potassium. And water. And what do you get? You get not the carboxylic acid, but the carboxylate anion of the carboxylic acid. And so used to writing sodium because that's the most widely used, but let's make it useful. you get the carboxylate anion of the carboxylic acid you would have used to make this ester, plus the alcohol you would have used to make that ester. So what's our N-propyl? What's our prime ethyl? Therefore, we get this R's 3 carbons, carbonyl. Now, don't put the carboxylic acid here because I'd mark it wrong because it is. It's the carboxylate anion. What's M? Sodium. Now, you don't have to put the charges there, but I will. And the second thing you make is the alcohol. What's R prime ethyl? And that's what you'll make. And we use these reactions to make things. And like I'll teach you later on, this is how they made soap back in the 1600s, 1500s, colonial days, until probably end of World War II, 1950s or later. And I'll teach you about the liquid soap, which is a little different than this, the bar soap. If you have bar soap in your house, which Dr. White uses in my bathrooms, I also have liquid soap, but I like bar soap better for taking a shower or bath. This is my preference. You're using a carboxylate anion. That lithium was way off in left field. There. And the question would be, what are the two products you would get if you conduct that reaction? Thank you, Joe. Thank you, Megan. Take your time. I think Calvin's done. And it's time for me to get to work. So if we look at this, by the way, you're doing organic chemistry. It's not that painful. Might even be fun. All right, let's take a look at this. What's different? Carbonyl, oxygen, carbons on that oxygen, carbons on the carbonyl. I have an ester. What am I reacting with? Ooh, lithium hydroxide. I'll write it like this, where M can be, in our case, it's lithium, could be potassium, or it could be sodium. And what do you get? You get the carboxylate anion of the carboxylic acid you would have used to make that ester, plus the alcohol you would have used to make that ester. What's R? What's R prime? And therefore, my carboxylate anion, 2 carbons, carbonyl, oxygen minus, what's my cation? Lithium. And then my alcohol, ooh, Ooh, a T-butyl group. Dr. White's happy. And that's how you do that. Now, how many of you have ever heard, and they're about only 10 or 15 years old, lithium greases? Have you ever heard about those? They sell them at Home Depot and Menards and Lowe's, and they're great lubricants like for the wheels and mechanism on my garage door and other things. And what's a lithium grease? It's really a carboxylate anion, where M is this. And turns out R is very long with the carbonyl carbon, about 16 to 18 carbons. And this is a very good grease to lubricate metal on metal for things that don't get that hot. Other lubricants, I just thought of something. I'm not sure which esters, but in the last 8-10 years, special high temperature esters are now used as motor oil for certain cars. And that's also a lubricant, if you think about it. And no, I didn't forget anything inside here. What would be the two products? I did forget to do this, but now I remember that you would get when you do that reaction. Thank you, Joe. Thank you, Megan. And for the others, take your time. Everybody's done. I better get to work. And if we look at here, what's different? Well, carbonyl, oxygen, I got a benzene ring, but that's not going to react with KOH and water, KOH, potassium hydroxide. So what I have here is an ester. And if I write my base like this, where M can be potassium, which it is, sodium cations, or I don't need the plus sign, or lithium, it can be other things too, and water. What do I get? I don't get the carboxylic acid, I get the carboxylate anion. Of the carboxylic acid I would use to make that ester, plus the alcohol I would have used to make that ester. What's our cyclohexane ring? What's our prime benzene ring? So I have my cyclohexane ring. And then R prime is a benzene ring. So I have phenol. And that's what you would get. Any questions so far? Tam, can you see that okay?
Yes, I can. Sorry, I was.
Oh, you have nothing to be sorry about. That's just
Um,
my way of saying you got a question. Because Dr.
Yes,
White
actually.
loves answering questions from students.
Quick question. I may be spaced out, but the first product, does that say okay?
The what?
Um,
Oh,
the
I made a
first,
mistake. You should have said, Dr. White, you made a mistake. Oh, no.
that's what my face was at.
Well, you were right. Oh, no, I'm going home. I am home. Oh, I'm so embarrassed. Shh, don't tell anybody. Thank you for pointing that out. And the answer is you're right, I was wrong. Well, in that case, I've got to redeem myself. Keep an eye on me. I already made one mistake today. All right, here's one for you. I got it right this time. What would you react with potassium hydroxide and water to make those two compounds? All right, thank you, Joe. I think Calvin's done too. And Megan is done. Everybody's done. So I better get to work. And what do I have here that's different? Ooh, oxygen with a cation. It's a carbonyl with carbons, a carboxylate anion. And the cation, M plus, M can be lithium, in our case, potassium, or sodium. And carbon with a hydroxy group, alcohol. And what do you react with a base? MOH is a base, and water, and that's an ester. And therefore, if I look at this, what's our methyl? What's our prime? Methyl. Therefore, what's my ester? Methyl, carbonyl, oxygen, R prime is methyl. So if you take that ester, react with KOH and water, this is what you would get. And that's how you do it. How are we doing time-wise? Ooh, we have time. This has nothing to do, public service announcement from Dr. White, sort of. I don't know if you look at the ads or where you live, you buy the food, but Jewel has a really good sale going on till the end of tomorrow on boneless, skinless chicken breasts, which I use a lot. It's healthy, it's good for you, and it's available. And their price this week is $1.77 a pound. Most places on sale are now doing it $2.49, so that's a real good deal. Now, the other thing I wanted to tell you is, and this is something all my life I've found to be true. If you're a good synthetic organic chemist, you're also a good cook. And I'm a pretty good cook, learned from my father, as you've heard. And I've done a lot of, over the years, experimenting myself. Synthetic organic chemists do that. And if someone tells you they're a bad cook, but a good synthetic organic chemist, they're lying to you. because throughout my whole life, all the synthetic organic chemists I know who are good were also good cooks. But stock up on the chicken breasts, they're a really good price, and Jewel has a very good quality. By the way, public disclaimer, I have no stock or get any kickbacks from Jewel or any other company. If you know anybody wants me to do commercials, let me know. All right, so that's how you react the base with and water with an ester called ester base saponification or saponification of an ester. I'll teach you later this specific reaction. When the ester is animal fat, you make soap. Carboxylate anions is a soap, bar soap. All right, now, there's a mistake here I've got to correct. At my level, it's not. It should be this. But for you, I'll put the 2 in. That's why I missed it. Now, let's have fun with my favorite reagent, the Grignard reagent. If you take an ester and react with not 1, but 2 molecules of Grignard, second step acid water, you make not 1, but 2 carbon-carbon single bonds. And you also make another alcohol. And this is a really great reaction. I used that when I was doing my PhD thesis. I ran this to make certain things I needed. Let's take a look at it in detail. This will not be on a test, but Dr. White's going to have some fun. I forgot to do it again. Organic chemists usually don't put that there, but for you, I will. We don't balance equations. Now, the first Grignard, remember, Grignards attack a carbonyl, attack that, and this gets eliminated. Remember, keep your eye on the carbonyl. And you get this ketone and this alkoxylate. And when you take the second step or first one, then you add the second amount or molecule of the Grignard. This is a ketone, and you know the Grignard attacks that. And second step, the acid and water will give you this alcohol. This alcohol, when you add acid and water, is made, because it's a base, acid, you'll make the alcohol. Now, this will never be on a test, but now you know how you form 1 and then 2 carbon-carbon single bonds. So let's take it for a spin. And one of the things I should mention, usually keep R prime small so you can distill this off, because it's low molecular weight, low boiling alcohol. And the other alcohol is usually not. So we start with this, react it with this. What do you get? What two compounds? Well, what's this? It's a carbonyl oxygen. On the oxygen, I have R prime. On the carbonyl, we have an ester. Then here, I've got two of something, carbon, magnesium, halide. And that's a Grignard. I keep on. This is don't write to 2 Monday. And what you get, keep your eye on the carbonyl carbon. What's attached to it is still there, R. Then you make not one, but two carbon-carbon single bonds from the Grignard. Remember, X here can be chlorine, bromine, or iodine. And this is an alcohol. You'll get a second alcohol where this is made. So if we come back here, what's our ethyl? What's our prime? Methyl. What's our triple prime? Remember, R's are like X, Y, and Z in math. Methyl. So I'm going to have my R group, two carbons, this carbon here, which is this carbon, is this. Here's my R group. I'm going to have bonded to that a OH and my not one, but two R triple prime. In this case, it's methyl. And then I'll get a second. This part right here becomes the second alcohol, and that's methyl. And that's what I've gotten as soon as I put in my hydrogens. And notice I made a very complex alcohol plus methanol in one easy step with simple things. And that's the Grignard. Anytime you can make a carbon-carbon single bond, and here we make two of them, 1, 2, that's a good thing. And this is. Oh, time for a special gift. Just a little gift, but a special gift from me, Dr. White. This reaction I will never put on test 3 or the final exam, a synthesis problem where you have to give the starting materials. You will have to give the product or products, but never the starting materials. That's my little gift to you today. A little one, but nice one. Oh, good, I remembered it too. All right, what two products would you get when you react that ester with those two steps, 1 and 2? I gave it away. I told you it's an ester. Bad, Dr. White. Ooh, see, some people are getting the hang of this. This is a tough reaction. Very complex organic chemistry. Doesn't it feel good? You can do it. Everybody go like this. Yes, Dr. White. You don't have to. All right, let's get to work. What's different here? Carbonyl, oxygen, carbons here and here. I have an ester. And now, what am I reacting it with? Well, first step, I have, two of something. Carbon, magnesium chloride. I have a Grignard. Remember, X can be, in our case, chlorine, but it could be bromine or iodine, halogen. Second step, acid and water. Keep your eye on the carbonyl carbon. That's where the fun is. What's attached to it is still attached to it. And now you make that into an alcohol. And you have not one, but two carbon-carbon single bonds you made from the carbon with the hydroxyl group to these R triple prime, which come from the Grignard. And then this R group, R prime, also becomes an alcohol. So if we look up here, this is R. This is R prime. This is R triple prime. So keep your eye on the carbonyl carbon. My R group, carbonyl, which now is an alcohol. And what's my R triple prime? I have two of them to that. And then my other alcohol, what's R prime ethyl? And that's the two alcohols. Now, this is a low boiling alcohol you distill off, and you know about distillation now. And you get the other one you could purify. And notice that alcohol, this one right here, I'll just call it A instead of the IUPAC name, which you and I both can do, but we won't. That's a pretty complex alcohol. And why would you want to make complex alcohols? Well, you can make esters and sell them as perfumes. By the way, probably one of the most lucrative areas of all of organic chemistry is being a perfume chemist. Those guys make bundles. When I got out of grad school, because I didn't work with esters, my PhD thesis, but I still applied to a couple of the big name perfume companies on the East Coast, like Givaudan and others. And guess what? No, we're not interested. You don't have the training we're looking for. So I went on to other industry of organic and had a lot of fun. Oh, speaking about fun, let's do one more. All right, this is going to be a challenge. Are you up to it? I think you are. Don't forget, after class, if you happen to have a bottle of vinegar in your house, pick it up, look at it and say, aha, I know there's acetic acid in there, carboxylic acid. By the way, you don't have to say the aha part. Thank you, Joe. Thank you, Tim. And everybody else, I think, is done. So if we look up here, what's different? Carbonyl oxygen, carbons on that oxygen, carbons on the carbonyl. Remember, carbonyl, carbon double bond to oxygen. And we have an ester. Our case, R and R prime are both methyl. Ooh, two of something. Benzene ring, carbon, ooh, magnesium, iodine, and that's a Grignard. Remember, X can be chlorine, bromine, or iodine. Quick question. When I write it like this small, can you see that okay? Give me a thumbs up if you can. I guess most of you can. If not, you can always ask, could you do it bigger? And then second step, acid water. And I should have done this up here. On test, I check. And what do you get? You get two alcohols. One where you make two carbon-carbon single bonds. That's very special, very rare in organic chemistry. And a second alcohol too. So we have R and R prime. What's our triple prime? This. By the way, that has a name. That's called the benzyl group, which I'll never ask on a test, but I thought I'd let you know. So let's look at the carbonyl carbon. What's attached to it, R, is still attached to it. And this becomes an alcohol. Then I have my, not one, but two carbon-carbon single bonds, the R triple prime. And you get this really complex alcohol now. And you get a second alcohol from the R prime. In this case, it's methanol. Keep it low molecular weight so you can remove it. And those are two products. Now let's take a look at this. That's pretty complex. But this is simple ester. This is simple Grignard. How would I make that Grignard? Well, this won't be on test number 3, but you just learned if I do this reaction, and this you don't have to write down, Dr. White's being an organic, synthetic organic chemist and having fun. I made the Grignard. How would I make this? Well, thionyl chloride from this alcohol. Again, this you don't have to write down. And this is how a synthetic organic chemist. This I can buy real cheap. It's called benzyl alcohol. And this is methyl acetate or methyl ethanoate. I can get that cheap. And I can get magnesium cheap, and thionyl chloride, isn't that? So that's all the different steps my training has been in. If I want to make this alcohol, how would I go backwards? And that's how you do it. But on test, I'll never ask all that. Okay. Oh, let's move on. How are we doing time-wise? You know something? I'm not going to rush through this because we got about 2.5 minutes left before we end. So I'm going to do something totally uncharacteristic. Hang on to your seats, fans. I'm going to let you out a whole 2 minutes early. And with that, I'm done for today. Actually, 2.5 minutes. Don't forget, tonight from 5 to 6:15, I have my office hour. If you'd like a different time, and if enough of you say it, let me know. And if I'm available, I can move things around. It's on Zoom, and you don't have to get in your car to go to ECC. I don't have to wait around after classes, which when I normally have my office hour. But if you have any questions with anything, stop by. Don't forget the labs due, distillation due this coming Wednesday. And with that, I'm going to say, gang gesund, be healthy. It's dangerous out there still. Wear your mask, get your shot. Most of you are too young to get the booster. I think this week, Thursday, I'll get my booster shot. I had to wait a couple weeks because I got my flu shot. Even though now they're saying you get both, I wait. And with that, bye, gang gesund. I will see you on Wednesday.